Black holes are the most terrifying, mysterious, and mind-bending objects in the entire universe. They don't just bend space, they break it. They don't just trap light, they trap time itself. And inside one, our understanding of physics completely collapses. Today, we're using AI-generated visuals to take you on a journey to the edge of reality and beyond. Welcome to Science Simplified. So, what actually is a black hole? It's not a hole in the traditional sense. It's not empty space. It's a point in space where gravity is so incredibly strong that nothing, and I mean absolutely nothing, can escape. Not even light. That's why it's black. Think of it like this. Imagine Earth suddenly compressed into the size of a marble. Same mass, same gravity. But now all of that gravity is packed into a tiny, tiny space. That's essentially what happens when a massive star dies. Stars like our sun are constantly burning fuel. That burning creates an outward pressure that pushes against gravity. It's a perfect balance. But when the star runs out of fuel, gravity wins. The star collapses. It shrinks and shrinks and keeps shrinking until all of its mass is crushed into an infinitely small point called a singularity. And that's when things get really weird. Every black hole has a boundary called the event horizon. This is the point of no return. If you cross the event horizon, you're never coming back. Not even light can escape. And here's where it gets even crazier. From the outside looking in, you'd never actually see someone fall in. You'd see them slow down, stop, and slowly fade away. That's because time itself slows down near a black hole. Einstein's theory of relativity tells us that gravity warps time. Near a black hole's event horizon, time slows to a crawl. If you were watching someone fall in from a safe distance, they'd appear to freeze just before crossing the event horizon. They'd get redder and redder, and then simply fade out. But from the astronaut's perspective, they'd fall straight in without noticing anything special at the boundary. And then, spaghettification begins. Spaghettification. That's the actual scientific term. It happens because gravity is much stronger at your feet than at your head when you're falling into a black hole. So your feet get pulled way harder than your head. You get stretched and stretched and stretched until you become a long, thin stream of atoms. You don't just get crushed, you get pulled apart. Atom by atom, until all that's left of you is a stream of particles racing toward the singularity. But what happens to those particles once they pass the event horizon and reach the singularity? Well, that's where science breaks down. The singularity is the point at the center of a black hole where all of the mass is concentrated. And when I say point, I mean infinitely small. Zero volume, infinite density. Our current understanding of physics literally breaks down at the singularity. General relativity says the singularity is an infinitely tiny point with infinite gravity. Quantum mechanics says such a point can't exist because of the uncertainty principle. The two theories, the two pillars of modern physics, completely disagree. That's why physicists like Stephen Hawking spent their entire careers trying to figure out what actually happens inside a black hole. Because if we can solve the mystery of the singularity, we unlock the secrets of the entire universe. Hawking discovered that black holes aren't actually black. They emit radiation. They slowly lose mass over time. And eventually, they evaporate. But what happens to everything that fell inside? That information has to go somewhere, right? That's the information paradox. And it's still unsolved. So, what's actually inside a black hole? Here's the honest answer. We don't know. Some physicists believe it's a wormhole to another universe. Others think it's a frozen star. Some think it's a baby universe being born on the other side. And others believe we need a new theory of quantum gravity to even understand it. The truth is, black holes are nature's most extreme physics laboratories. They push the boundaries of what we know. They challenge our understanding of space, time, and reality itself. And that's what makes them so beautiful. But we are making progress. In 2019, humanity captured the first ever image of a black hole. In 2024, we saw it in even sharper detail. And with new telescopes, like the James Webb Space Telescope and future AI-powered observatories, we're getting closer. We may not solve the mystery in our lifetime, but every new image, every new simulation, every new AI visualization brings us one step closer to understanding the most mysterious objects in the universe. So the next time you look up at the night sky, remember, out there, somewhere, gravity is breaking the rules. And maybe, just maybe, the answers to the universe are hiding inside those terrifying, beautiful, mind-bending objects we call black holes. If you enjoyed this video, hit subscribe. I'm visualizing the entire universe, one mystery at a time. And trust me, we're just getting started.